All right, why don't I get started on PRs here, and then we'll move on to discussing Blue Store Ono. So I saw two new PRs this week. One was from Josh to speed up caps and cap updates in the monitor. Josh, I saw that Joao had reviewed that. It doesn't look like we changed default behavior, right?
That's right. Yeah, I think he was just confused. The default behavior doesn't change. It's only a niche use case, so we just had an option to avoid parsing in that case.
So I'm not super familiar with this PR, but are we primarily limited by all of the object creation and deletion using that Boost framework, or what are we seeing now?
Um, well, right now this option just skips the parsing entirely. When the parsing is enabled
Okay,
for the OST capabilities, I think we are limited by. I'm not sure if it's the object creation necessarily, but that's my intuition.
okay,
A whole bunch of different calls within Boost Spirit showed up in the in perf.
okay,
But
makes
but
sense.
without the parsing, as we seem to be limited more by RocksDB, perhaps, or some kind of locking in the monitor. Um, with the script to analyze the logs mark, we still saw like 1 second pauses running on top of tempfs for compactions, which
Wow.
is kind of surprising to me.
Yeah, yeah. If I remember right, though, that was about. I don't think I saw quite 1 second, but I was getting kind of close to 1 second on the Fishy Analysis running on NVMe drives as well. So it's maybe kind of in the right range.
I wonder if there's some kind of tuning we're running into there what we could change with
I
the
think
RocksDB's like right blocking behavior or something.
I have a feeling that Gabby's PR might help a lot. We'll
Well,
see.
hopefully not in the monitors though.
Yeah, that's true. How often were we seeing? Sorry, I don't remember on the monitors. When we ran that script for looking at the RocksDB compaction statistics, were we hitting compaction very often, or was it kind of slow, like intermediate, or sorry, intermittent?
Yeah, it was pretty frequent. It looked like
So we're
over
actually
30.
pushing a lot of. Oh, go ahead.
Yeah, I guess we're pushing a surprising amount of. I mean, the database itself is pretty small. It's like on the order of 30 megabytes or something. Um, but I guess those levels are initially small enough that we're still running into a lot of compaction.
I wonder if we have any similar issues where we have a lot of tombstones and a lot of deletes happening. If there's like a lot of stuff that's getting in that actually is like temporary
That
data.
could be. Could be.
If
Yeah,
we
it might be worth investigating further if we want to improve monitor performance more.
it could be interesting just to try an experiment where you create much larger buffers in RocksDB in the write-ahead log, the same way that we do in BlueStore, and see if that reduces the amount of write amplification coming in. That's why we have such huge ones in BlueStore. It's kind of ridiculous how big they are, but it seems to be how we can get around having like lots and lots of keys end up being put into L0 that are promptly then like deleted really soon afterward. Maybe we're doing something similar with the mon.
Yeah, maybe. I don't think we're deleting keys quite as aggressively as the OSD does, but it's worth checking.
Okay, interesting. Okay, let's see what's next. Change the default value of OSD async recovery min cost. I don't even remember that option. So yeah, or Josh, do you know how that affects things? Because
Ye-
I don't remember.
Yeah, that's basically the threshold at which async recovery kicks in. And the PR proposes that we reduce the threshold so that we can do more async recovery. And this is based off of some testing, internal testing that was done by some of the folks at Red Hat. And they saw that with the default value of 100, they saw a lot of async recovery happening on especially for RGW workloads, They saw a lot of async recovery happening on replicated pools, but not as much, or like almost zero on EC pools. Now, it's totally possible that the workload they're using, or the setup they have, is not able to induce async recovery. The threshold is not able to cross the threshold of 100. But their proposal is that since there is no harm in having more async recovery, we should just reduce the threshold. And there's been some discussion on the PR. If you saw, I think Shay, I think he earlier proposed, he said that they are using a min cost of 1 in their cluster, and that's been the case because they want more and more async recovery happening. But I do agree with his latest comment that there is a caveat that during upgrades, if you have, or not just upgrades, when you have mixed clusters running different versions with different min costs, it is possible that choose acting does go into a loop where we might just not want to go there. We've seen issues like that in the past. So we should only be changing the cost when we have only one version running in the cluster. So I have to think about that a little more, and then we can see how we can implement that. But in general, it's a good idea to reduce the threshold.
Right. Let's see. Those are both of the two new ones that I saw. We have one closed this week from Majian Peng. That was enabling rocks to be pipelined rights. I still think that's actually not necessarily a bad idea in general, but it turns out that when Majian Peng did more testing, it looked like it was not really having much effect, and that it wasn't actually affecting a whole lot of IOs, that doing that was not as impactful as he thought it would be, I guess. So anyway, he closed it. Maybe someday we'll revisit that. But for now, it's fine. We have plenty of other things to worry about. So let's see. Updated PRs. Majian Peng also has another PR for reducing buffer list rebuilds. Radek reviewed that first, and I think maybe even was looking at a more general solution for it. But he approved the PR, and Igor also approved it. It did go through a round of testing, and it looks like there were some failures, so it might need some fixes. So back in Majian Peng's hands now to see what's wrong. Also, optimizing the lockup BlueStore writing process. Oh, this is the one that no one wants to touch, but Kifu actually said he was going to in the PR, so my hat is off to him for taking the time to look at it. So hopefully Kifu will be able to make a determination of whether or not we really want to take this on or not. Beyond that, lots of stuff in the no movement category. Probably still the ones that keep coming back that we need to look at are reducing ONode memory usage. So both Igor's PR potentially, and then also the thing I wrote a while back, almost a year ago now, to separate out the block cache into multiple block caches per column family, just to allow us to handle block cache for ONodes and block cache for OMAP separately. Also extents and all the other BlueStore metadata. So those still need to be worked on. Maybe after I'm done with this AIML stuff, I can get back to it. That's it, as far as I saw. Anything I missed, guys? All right, well then, Adam or Gabby, would either of you like to talk about the things that you've been looking at in terms of ONode refactoring? Adam, I know you had a document that you had sent out earlier. Maybe we talk about that first, and then Gabby, you can talk about your stuff.
Well, sure, I can. I mean, that's not much to. I mean, basically, Mark, it's just what I told you. We talked some time ago in Barcelona that it might be nice to have just the same stuff on disk and in memory and be able to operate on that. And as having some free time I just constructed a proposal how can we do that, and it's just what it is. I mean, I'm not even supposing that maybe that we definitely should do it, but I like to put it as at least as a point that this point in a space of possible solutions exists. There is a cost. Metadata will be much larger. There is a benefit right after you get access to your metadata, either by getting it from RocksDB or reading from disk or whatever. You can access it as any other data structure. Yeah, so that's it.
So, at different times in the past, we've talked about things like completely ditching encoding and just writing the buffer list directly into RocksDB, or potentially a gamer like var encoding and anything that takes a lot of time, I guess. Or maybe a more exotic thing that might be storing an encoded form of the data in memory in Ceph and then only doing decoding when we actually need to access something. I guess the thing that I have seen keep coming back over and over again is that we're being asked to reduce CPU usage. People want to be able to run OSDs with 1 or 2 cores and have the rest of the system available for hyper-converged processes, other things, user processes, other, whatever. Right now, with NVMe drives, a BlueStore-backed OSD can easily take between 10 and 14 cores, from what I've seen, when faced with a very, very heavy random write workload. So I guess my question for everyone here is, what are the things we can do in the OSD to, without, Crimson will eventually be the real answer, but in the meantime, is there anything we can do in classical OSD and BlueStore to make us more CPU efficient?
Can I jump in?
Yes, absolutely.
Yeah. So I came from a different kind of system, which was heavily focused on performance. It's like, unlike Ceph, which the algorithm allows to grow, the system could not grow beyond 16 nodes. So 16 nodes was the absolute maximum you could use. So we were always been forced to squeeze as much performance as possible from each node, because in Ceph you could always say, you know what, take another 100 nodes, they're cheap, so use them. We had like, each one of them was extremely expensive. Every time you add another node, it's hundreds of thousands of dollars. So not very common. One thing I notice again and again when looking at the code, and it's very different than the way I'm used to, is everything here is strings. I'm used to seeing stuff in binary format. Strings are comfortable for debugging, but it's not something that computer is comfortable using. And in many levels, strings tends to be arbitrary size, while binary formats tend to be the same size. Strings compare takes longer than comparing binary format, and strings, at least in the part of the code I've seen, they tend to always do dynamic again. So the strings start in one thing, like you add a string with a prefix, then you add the string itself, then a suffix, and so on. So every time you're doing this is dynamic allocation, release, allocate, release. So I think an easy target would be to move away from string and concentrate on binary format from whatever is possible. So one example I gave in the O node is the attribute format. So we have in every O node, we have map of attributes, which is strings. So like the way I'm used to seeing things like this is that you have, if the attributes are coming from a predefined set of attributes, then you enumerate them, and instead of writing the attribute name, you just have an index saying that's the attribute. And we, the code, shouldn't care about the name. We should just use binary compare, binary operation. The strings are only for the users, but if you need them for debug purposes, then there's always a debug function which can access the tray stuff. That's the easy case. If your strings are coming from a much bigger pool and you don't know the definitions, then you could create translation table on the fly. And I suggested doing this one per thread, where every time you see the client is coming and it's passing inside the string. So you check if you have it on your hash table. If you do, then you immediately translate this to a binary index, and then that's what you see inside the OSD. The OSD should never see the string afterwards. If you don't have it, then you create a new entry, get back an index, and you pass and you start using this. So that way you gain few things, right? I mean, you shrink the size of your data. The compares are cheaper, and you don't do dynamic allocation. Is, for example, in the ONode, all the attributes, they're using hash table. I'm not very familiar with the way C++ is doing hash table. I know many years ago, people suggested that when hash table got very few entries, they should just be using array, because hash table are efficient when you have hundreds of attributes. But if you got just few of them, then you should use array. I don't know if this is what C++ is doing, but if it's not the case, I would suggest just create an array. I mean, how many attributes are you going to have? You're going to have 10, 20 of them? It's probably cheaper just to scan the array looking at you than than running hash table. And you could save in performance the hash function. And hash function also tends to have these ugly things in which the memory location is unpredictable because of the way we like to randomize the option. Then you tend to move our free cache into DRAM, which is very expensive. And say you have, if the index is a 2-byte index, and say you have 32 entries in your map, you could easily create like an 8-byte value with 4 times the index, and then run the compare in 8 bytes. So you could scan 32 entries very quickly. You're just doing 8 compares, and then inside you do internal compares. So I don't know, like maybe 12 compare the most. And that's a big one. So trying to use more, I know it's easy. It's like, it's the most natural thing to use, and we love them. But performance-wise, they tend to take more memory because you need some space. You keep the key, you keep the data, you do dynamic allocation in small sizes. So there's always some overhead for them. So go like the first things coming to my mind. Then the other one for the ONode, I was suggesting that if we can identify that portion of the ONode fixed. So we know all ONodes have a fixed part, and then there's dynamic part, which can grow and shrink. So we could use relist with ONode from the fixed size. So all of them just going to have the same amount of space, and then the last entity should be a pointer to a dynamically allocated area, and you could use it using a buddy system. Then you could allocate the part which is changing, but the part which is not changing, you don't have to copy again and again, because that thing you could do in place. So if you change 1 byte, you don't have to copy the full entity. And another thing to do here, if all your data structures are simple memory data structures, you don't need encode and decode. You just map this thing into a binary format and you just dump it as is. The last thing for the pointer, you need to do some more interesting thing. But the first part, which is constant, you just write it as is. You don't need any formatting. So that's way.
So Gabby, this is a little old at this point, but is the one that I was able to quickly find. This is I pasted a wall clock profile of the OSD under a 4K random write workload. So this is kind of a standard case where we really stress certain parts of the OSD, specifically the KV sync thread. And it's not necessarily definitive that this is, where bottlenecks creep up. But it so far it seems like it's done our profiler has done a fairly good job of pointing out areas where potentially we can make improvement.
So I don't know how to read this thing.
So this is basically time spent in different parts of the code under a 4K random write workload, of a specific OSD. So like if you go to line 415, you'll see
Slowly. Wait. 415 takes me some time to get there.
Yeah, no problem.
Yeah. Yes, I see it now. Before K value sync, 1,000 samples.
Yes. So you can see in here that, for instance, we're spending a fair amount of time in wall clock time in the inline skip list in RocksDB, doing key comparisons.
Mm-hmm.
So in this case, this is because we have such large buffers in RocksDB, where they're filling up with so many keys that it's taking a lot of time for RocksDB to actually walk through and do comparisons, figuring out where keys should live for ordering purposes. We have such big buffers, though, because we're trying to avoid a situation where we have temporary keys due to pglog, presumably, that are going into the database and causing extra write amplification.
Just one second. Mark, sorry. Question. Yeah. Is this code trying to sort all the key data so it could be the stage sorted? Is this trying to create a sorted table from what we have in memory before we write it to the disk?
So yes, see how earlier on it's memtable add. This is during this column family insertion, and we see memtable add called on line 430. So that's basically we're iterating through. RocksDB is iterating through all of these, doing key comparisons to do that add into the memtable.
Because everything is sorted. Do we really need? Okay, that's maybe a bit changing the direction, but why do we use key value database for the O nodes? I don't see much benefit. Why don't you use just an OLTP kind of database like MySQL? I don't know who's now the best classic RDBM, but OLTP, they are used to writing small entities and they don't need to sort them. I mean, we don't care for sorting. We don't need the meta run, all these runs. The things about key value and LS entries, they are great if you have big objects and those objects are not changing very often. But with O nodes, they are extremely small and they keep changing. So you keep creating more and more versions. And when you read them, you have to visit that many levels until you construct them. And it's a tiny object. So I understand we need the persistency that RocksDB give us, but maybe we could just use somebody else, something which is tuned for small write. OLTP, this is what they do, right? I mean, OLTP, they use to your bank record. They are all very small. Take some changes and they destage them. Did we try comparing RocksDB to MySQL just for the O node, not for the object itself, but for the O node state?
So Sage isn't here to really kind of give the what he was thinking during this, but I can kind of give you my perspective when this was all being written. I think that Sage really, at the time when BlueStore was being written, wanted to be able to get all of this data in one transaction going into the write-ahead log in RocksDB, especially for the possibility of being able to do deferred writes. So, back then there were SSDs around, but hard drives were still really popular, right? So we were trying to figure out a way to be able to support both use cases. And for hard drives, having the advantage of being able to do a single transaction with both the onode metadata and potentially also, if it's a small I/O, a small amount of data right into the write-ahead log, was really attractive.
But
I think
this is what we're trying to do with CStore, right? I mean, that makes sense to me, that you stage the metadata with the data. That's perfect, makes sense. But separating the entities on the LSM tree, I'm not sure it's the best fit.
I'm not sure that RocksDB in the long run really is a great fit either for a lot of what we're trying to do. But having said that, with Crimson, we're changing that direction a lot, right?
Yes.
I think the question right now with BlueStore is, given what we have, without completely changing the RocksDB backend, because we've actually looked at a couple of things. We did try replacing it with LMDB. I actually wrote an updated version of another LMDB backend that someone else had made a while back, and it was slower. We couldn't do it as fast as RocksDB. It probably was not fully optimal. There are probably things we could have done to improve it, but the early prototypes and early tests didn't really show a significant improvement with an easy implementation. So maybe we could have done better if we kept on working on it, but it certainly was not a dramatic improvement just with a basic implementation. MySQL or Postgres or something else, we could try something like that. I think, though, if we were going to go down that route, I'd advocate we just write our own thing. Right? Specifically, that we write our own write-ahead log, and whatever we have sitting behind it is, its own thing. But
Yes.
But that we do the write-ahead log ourselves.
You know what? I think that actually might be the best solution. I think RocksDB is great because it can give you a way to develop things very quickly. You just throw it here, and you got stability and reliability. If you develop your own write-ahead log built to support your own internal mechanism, I don't think anything else could compete. But this is what BlueStore is going to give. Sorry, CStore going to give us, right? It's exactly what CStore is doing. So
well,
this is something.
I'll be honest, I haven't followed it recently, so yes, probably, but I haven't talked to Sam in a while. So you may know more than I do at this point. What Sam's working on with it.
So that CStore is writing some log structure file system. So everything is flowing there. The metadata and the data is going there. So you could still do the sequential write or moving forward with zone namespaces.
Yeah.
But at least I hope that we're not going to do separate log for the onode. I think we don't need to.
Okay.
Sam said he still want to do them, but I think it's open for negotiation.
Okay.
But
okay.
Other than that, building something else just for the onode is probably the best approach we could do.
So there was a prototype from Intel a little while back from Lisa, where she was trying to take specifically pglog and just write it out to BlueFS directly without writing to RocksDB. So not exactly what you're doing, Gabby, but hers, unfortunately, it didn't handle dynamic sizing. It just allocated a very large block, and then hopefully the pglog entry fit inside it. And that was as far as that one went. She didn't think that she saw a significant improvement with it, so it kind of just ended up being abandoned after that. But I'm not convinced that we really gave it a fair shake, or at least the idea of trying to change how we write pglog entries a fair shake. That's why I'm very excited about what you're working on, because I think that there's still potential and possibility there to really improve what's going on. whether or not that translates into something even bigger in terms of looking at how BlueStore stores data and how we write ahead log and how we actually write transactions out, I don't know. Maybe it's too much work at this point, but certainly this is, I think, a rich area for performance improvement from the traces and wall clock profiling that I've done. There's this, and then also overhead that we have in the OSD TP threads, and then there we see some other things going on. But that's why I posted that profile, just because it might give you kind of an idea of at least where we're spending wall clock time.
And actually, sorry, one thing, I'm coming back to something I said in the beginning. Big part of the workload there is the sorting, right? I mean, before you create a run, before you stage a run by RocksDB on the LSM, you must sort everything. So if you shrink the keys, the sorting is going to be faster. I mean, it's still n-log-n, but at least the constant could shrink. If your keys, for example, if we're talking about RGW, and a key could be hundreds of bytes of string, and comparing hundreds of string bytes is expensive. But if you make it to be a binary format, but if you compress it on the client side, you will never see the full key. It may be like a 512 byte of key could shrink to 64-bit binary compressed format. Then comparing them could be much faster. And you could also use...
Yes. I also think what you're doing with reusing keys is going to be very important, because I believe that if we do that, so we no longer have tombstones, I think we can shrink the buffer size for the mem tables so that we're doing compactions more often with smaller amounts of data. And I think that's also going to help. And we won't see the right amplification we do right now when we try to shrink those. So all this stuff is kind of tied together, right? Like O-nodes and how big they are, and whether or not they're encoded or not encoded, and pglog, and how many pglog entries we have coming in, and how often they're tombstoned, and when that happens, and how we have transactions hitting the write-ahead log. All of this stuff is kind of interrelated in really complicated ways. But I think all of this work that you're doing and work other people are doing, if we can start experimenting and finding out kind of what things affect things in different ways, I think it will help us learn what's useful and what's not, and what we should be doing.
I think that the idea, like Gabi was talking about, of potentially having O-nodes outside of RocksDB is pretty interesting, because it's not just the CPU overhead there, it's also like the write amplification and read amplification, which can matter a lot even on hard disk. And when we have these tremendous amounts of objects, like for RGW, they have like billions and billions of objects, that's tons and tons of O-nodes, which don't necessarily need to be all assorted together like that. I mean, RGW is maintaining its own index, and for the OSD's purposes, listing O-nodes doesn't necessarily need to be a low latency operation. It's mainly used for backfill and scrubbing. These are background things. So I think that might be worthwhile to try to figure out, like, if there's some kind of prototype we could do with O-nodes outside of RocksDB and see what effect that has.
I think, Josh, if you pull O-nodes out of RocksDB specifically for hard drives, we'll need to implement our own write-ahead log, I think. Does that make sense to you? Because we'll still want to have a single transaction hitting the disk to avoid lots of seeks, right?
Yes.
But then once we do that, if we had our own write-ahead log, then we could send off the stuff to RocksDB that RocksDB needs, and then we could send O nodes back to the disk, doing whatever we want, as long as we controlled the write-ahead log.
So
Yeah, we could still defer writes through RocksDB if you wanted to.
if we're using ZoneFS, my understanding that as long as you're writing forward application, and writes tends to be fairly quick, even on QLC drives. So just use a simple log and flash the data forward, always move forward. Don't try to optimize access. I mean, what LSM is doing, the reason it's sorting this is because they need to build a mechanism, and the sorting is needed because you need to merge levels. But if you keep writing forward and it's just write ahead log, which every time you wrote something safely, you could put a checkpoint and you can discard it and it could be cyclic, then you could just use something simple. But again, it's not going to work with spinning drive, as you said. Spinning drives, you're going to kill them doing this. But zone namespaces might be a friend here.
Yeah.
If you have dedicated zone just for this.
I think the hope with RocksDB and BlueStore, right, was that that the overhead for this wouldn't be so bad on Flash that we could still do a reasonable job with it. But you're absolutely right. Having the BlueStore design is still kind of trying to have the best of all worlds, right? Like let hard drives still be fast, but make NVMe faster than it was in the file store days. And it is, right? I mean, a BlueStore OSD for NVMe is still usually faster than FileStore was. So we got some benefit from it, but we're hitting the limitations, I think. We can't, CPU now is what holds us back. And I think you're right, simpler is what we need to be fast with Flash. We have too much overhead, too many things going on.
Because the reason with LSM, all the complication is because they're retrieving this object. But we're using write-ahead log. Write-ahead log, you're not going to retrieve them. In most cases, you're never going to read them again. You just write them, and once you just take your data elsewhere, you're going to forget them. You don't need to build fancy indexes for them. You don't need all kind of sorting, because in case of failure scenario, okay, you'd go back and you would read them one by one, and nobody cares. It's going to take minutes, maybe it's okay. It's not going to, nobody going to say, now go fetch me what you have on disk. You don't need it. You have it in memory. So we just need a write-ahead log. We don't need an LSM. And there might be even write-ahead log open implementation we could borrow. And surely for zone namespaces.
In the past, like for FileStore, we wrote an write-ahead log, essentially for the same reasons. I don't think that part is necessarily that complicated.
Shouldn't be. I mean, people have been doing this for like 50 years now. Every database in the world is using write-ahead log.
Yeah. But I guess I do want to point out that with BlueStore, I'm not sure we should be thinking so much about like zone namespace or super fast devices. So that's kind of where CStore is going to be coming in say a year or two once it becomes more stable, and that's going to be like fully optimized from the ground up for that use case. So I'm not sure it makes so much sense to try to shift BlueStore in that direction so much as improve its efficiency for like slower SSDs and hard disks.
Yeah, that's kind of the question, right, Josh? Is like, is there low-hanging fruit in BlueStore? Are there simple things that we can do, or even moderately simple things we can do that improve this to the extent that we can, without turning it into another copy of CStore?
So I mean, there's a tricky thing without zone namespaces. If you're writing short write one after another, you're going to create crazy write amplification. So zone namespace was built from scratch. Sorry, the design there was built to support this kind of write logs because nobody's trying to collect things, nobody's trying to do anything. The only thing I've tried using many years ago, we did like 10 years ago when SSDs were still young, we tried to do the the translation layer, try to disable the translation layer so you'll be able to do that. So I don't know if this is a valid option. Can you say, you know what, if we have the firmware, maybe you can disable the translation, the flash translation layer, and then we could do the write ahead log, and there's not going to be any write amplification because nobody going to do garbage collection. The problem for us is if we do small write one after another, and the garbage collection is going to kick in, they're going to amplify the write, which is not what we want. So I don't know how this thing going to work.
Just in terms of your PG log stuff that you're doing, though, that's I think a very valuable thing to be looking at, because at the very least, it's something that might reduce the amount of keys going into the database significantly, and delete some tombstones, very specifically tombstones. And pglog is kind of nice from the standpoint that you're right. You don't go read it during normal operation. It's only read when you have a case where you actually need to read it after OSD reboot. So my hope is that it's not going to be nearly as impactful as trying to like change the on-disk onode format or something.
And actually, you know what, now that I think about it, there's actually a potential problem. Because if we're going to recycle the keys, it means we're going to create more and more version of the same key, which means LSM will need to compact. We'll have more and more stuff to compact. Because naturally, if we don't recycle keys, then usually once you wrote the onode a few times, it's not going to change again. But now we're just going to change them again and again and again. Hopefully they're going to be changing in memory, but I don't know if you're going to create an extra runs of them, and you're going to see in every level of the LSM, you're going to have another copy of the object.
They'll be really hot, right?
Yes.
Those pglog key value pairs will be super hot. So hopefully they won't be in like a very deep area of the LSM. It should be all sitting in like L0, L1.
So maybe we could allocate enough memory for them. Say like, I don't know, like your buffer space should be big enough to hold 3,000 keys in memory, that you can always have them all in the same level.
So right now we use 256 megabyte buffers for mem tables, which should be easily big enough, I would think.
I mean, the typical size we see for the in-memory pglog is like around 120 megabytes without default settings today, so that should be plenty of space.
Okay.
Is this a per PG group? Because every PG group got its own LSM tree, right?
And that's total. It's all going into
so you have to divide it by 512. How many PG group 12s? I know not all of them going to be active in the same time, but what's the number of active PG group?
You can assume like around 100 PGs per OSD, and you can assume that they're all active at the same time, roughly.
About 100 active. So if an object node...
that figure 120 megabytes is for the entire OSD, though, so that's like 12 megabytes per PG, roughly.
12 megabytes per PG?
Yeah.
Just for the nodes?
Just for the PG log.
Yeah, okay. Yeah, that should suffice. But we should just make sure we're not going to trash the system by just keeping writing everything again and again and again. Maybe the best thing to do, I think, I need to see how I recycle the numbers. Maybe the best thing is to always recycle the last one first. Or the first one, I don't know. Like if we need to do like FIFO or LIFO, need to see which one of them is better.
Yeah, I think the Roxby stats will be forwarded there in terms of how many keys end up going to the lower levels.
This is why it's very seductive to just use like on-disk ring buffers, right?
Yes.
To just get Roxby out of the picture entirely and just have some contiguous space on disk that you write into for this.
Yeah, but how you get away from write amplification? So I'm again going to say this. I know I said a few times. Zone namespaces might be our best friend here. Just write forward. There's no write amplification. Write speed is good enough. I mean, they can do easily 20,000 IOPS per second, 20,000 IOPS, even if it's like small ones. So it's okay to do all these small, stupid writes. Spinning drive is going to die from this. Unless you got a dedicated spinning drive, because if you keep writing to the same location, and then the head never have to move. So actually, they can, even to give you good enough performance, if you could take one drive and nobody is using this except for this write ahead log.
One thing that we kind of have moved toward, though, is telling people that even with BlueStore, we expect that if they care about performance, they should have some kind of flash in the system for write-ahead log. I mean, that's pretty common at this point, I think.
Yeah, but write-ahead log without zone namespaces might be a problem because you can kill it with write amplification. I mean, it's something we need to verify. Yeah. Actually, it could be very interesting to see how spinning drive is going to behave. Because, you know, spinning drives, they also got their own internal cache. And if they are battery protected, then the writes tend to be very small. So essentially, you're going to use them as a non-volatile RAM. I think now they have like 64 megabyte of battery protected memory for cache. So if you're using just one of them and you keep sending small writes, it's to finish immediately. And if the drive can put everything in his local cache, organize them, and then send them, and we never moved ahead, we just move one direction, then they could stage it.
So the big thing there is, right, battery backed memory, you know, RAM. If you have it, and even on flash drives, we've seen that historically in the older days, sometimes you would have a supercapacitor backed cache where you can issue a flush request to the disk or to the drive, and it can immediately respond saying, yeah, it's fine. You know, on the assumption that if it loses power, it can write the stuff out anyway. But we even saw flash memory, SSDs, where they didn't have this, and it, you know, a flush request could take a significant amount of time. It was very slow. So in terms of the user experience and the kind of support requests we got, sometimes it very much would depend on whether or not the drive actually had this kind of battery-backed cache. So if we're going to require it, or even right now, I guess, you know, we see a very, very big disparity between things that have this and or hardware that has this and hardware that doesn't.
So I think we talked a bunch about the detail on this. Because I'd like to go back more to the in-memory portion.
Sure.
How can we kind of reduce the memory needed for our nodes or for BlueStore metadata in general? Like Igor or Adam, you probably have some input here because there's a lot of the different things in practice.
Well, let me jump in, starting with a previous topic and then proceed with some thoughts on BlueStore node. Well, first of all, in my FIO plugin for BlueStore, I have an ability to simulate pglog load. And I did some investigation on that a couple years ago. And, well, it's still possible to do the same right now. But I recall I saw around 20 to 30% of in performance improvement when disabling pglog load. So that was a random write scenario with or without pglog simulation. Just to so this way we can try to estimate our benefits from using from not putting pglog data into RocksDB. Secondly, in my opinion, we might have some issues with having separate pglog or separate write-ahead log along with putting some data into RocksDB. When the issue comes from the need to have transactions semantic on write operation, and hence we need to update both this standalone write-ahead log and RocksDB in an atomic manner. This doesn't look a simple task, in my opinion. And more general comment is about BlueStore, which looks like a pretty general and flexible solution from one side, but this brings a lot of complexity and which negatively impacts the performance and memory usage and things like that. And it looks like one of the possible way in improving things is to making more specific solutions, maybe based on BlueStore or something. For instance, remove spinner support, or something else. There are plenty of such stuff which is pretty outdated from one side and brings a lot of complexities from another side. And another one of the example is probably the simplification of this on-node structure. So right now we have pretty good flexibility in block sizes we in on-node, for example. So at logical level for each node, byte granularity, which probably is an overkill. The same, we provide some, in my opinion, excessive flexibility in blob alignment, in shards alignment, which we need to maintain for keep data in RocksDB in less chunks. So if we talk specifically about BlueStore in a node structures, then probably the way to go is to simplify to reduce the amount of supported features, to reduce the flexibility and provide maybe more tuned solutions, say for immutable objects or things like that. Well, very general overview, but that's what I have.
For the immutable object case, like we already have these hints that RGW is passing us, saying when it's writing its data, these objects are immutable and or append only. So we might be able to do more optimizing those within BlueStore already, just based on those hints.
Yeah, the same might apply to small objects, maybe plenty of other stuff. So, well, again, supports for deferred operations, which is redundant for flash drives. So the issue is that BlueStore is a very general purpose That's why probably one of the reason why RocksDB's or KV's store is used provides more flexibility than having some fixed structures and things like that. So you have great flexibility in adding different kind of information into KV store, which you might don't have with some more fixed data structures.
And so, I mean, even without reducing some of the flexibility, we could add more information to BlueStore in terms of like the hints it's getting from clients. Like for RBD is already sending hints about its object size being like a 4 megabytes, for example. For CFS, it's similar. It could perhaps be sending more hints about kind of that same kind, what its expected I/O profile or at least object profile is.
We're past time here, but Josh, you had also mentioned wanting to talk a little bit about O-node shrinking. Do we want to quickly get into that, or should we punt for next week?
Maybe we could punt for next week. I think we're going to talk a bit about that one of the papers next week as well, but that could probably take less than an hour. So, can you continue the discussion?
Sure. So I did link Igor's O-node diet PR in the chat window for folks that are really interested in this. That might be a good thing to look at and look over for the future discussion. I also can link, I had mentioned the double caching fix PR, which I can also link here. I do think that probably even more important than this is figuring out how to reduce CPU usage. If we can do both, it's even an even bigger win. But I think it will be easier for us to argue for more memory than it is for us to argue for more CPU. Just in general, that's the feeling I've gotten.
Yeah, in some cases they're related, right? Like if you reduce memory size, you fit more in cache. You don't need to go to RocksDB as much, therefore using less CPU fetching from RocksDB. And
yes. Agreed 100%, Josh.
To get non-volatile memory, opt-in kind of things. I mean, if we got opt-in, then most of our problems will go away.
Opting DIMMs, yes. Right?
Sorry?
Opting DIMMs, yes, but not opting.
Yeah, sure.
Yeah.
Opt-in DIMM, but even a very small one, like the smallest they got would be more than enough. I mean, we'll never have, we could do a recycle buffer for the write-ahead log, use it there, and then you could throw away RocksDB.
That's we're supposed to be getting some. We've been supposed to be getting some for the last 6 or 8 months. Theoretically, they may show up at some point here, but COVID makes it tough. As soon as we get them, though, this is exactly the kind of thing we're thinking about doing with them.
I've got some experience with NVMe DIMMs for last year, half a year, and I've been trying to implement a sort of RocksDB replacement using NVMe DIMMs. Right now I have a working implementation which is okay from functionality point of view. It's embedded into BlueStore and is able to replace RocksDB. But I can't say, well, I did a bunch of benchmarks, maybe not very excessive, but well, some of them. And I can't say, well, I have some additional thoughts how to redesign my current implementation and things like that. But what I can tell for now is that using NVMe DIMMs not that straightforward in terms of achieving great performance. So right now I don't see much benefit of using NVMe DIMMs comparing to RocksDB on past Intel devices, Intel flash drives. Well, again, I have some thoughts how to try to improve that, but what I'd like to highlight is that it's not that trivial and straightforward task as it looks like. And one more comment is about this hardware itself. Bringing the requirement to use this hardware limits the usage, well, limits the auditory which might use Ceph and this store. So right now there are pretty high requirements on the hardware which supports these NVMe DIMMs. This probably tend to change eventually, but for now it's definitely not the common solution, and it's pretty expensive.
Guys, we do intend to spill this discussion till next week, right?
Yeah, we should probably wrap it up.
No, I'm not pressing that, but is there a limit to flexibility of targets we want to achieve? Because in the same discussion we talked about spinners, NVMEs, Optane PMEMs, and I mean, what is the target I should think about for the next week? Because now it's too many options.
I think
reducing CPU usage, fine, that always works. But what is that? Do we reduce functionality, trim some unnecessary logic we have in ONodes? Do we have some idea?
My take, Adam, is that for BlueStore, we should target hard drives and drives primarily. And if we can use Optane DIMMs or other technologies like that as an easy drop-in, maybe we do so, but not as the primary goal. And I think for Crimson, we target NVMe drives with PMEM as kind of the target. That's my take.
Cool. So we keep targeting spinners still. That's fine.
Yeah, I think so for BlueStore. I think we have to. Josh, does that seem reasonable to you?
Yeah, I think that's a good summary, Mark. As we're discussing a lot of these things, though, a lot of them, like in terms of ONode structure and format, and kind of what if we could make things more specific for certain use cases. I think a lot of those same ideas could apply in general form to C-Store's conception of how it's storing ONodes too. I think C-Store is definitely going to need to go in the direction of not doing encoding and decoding on and off disk, for example.
Yeah. One thing I've been wondering about for a while, and we should still wrap this up soon, but is if our concept of storing data structured in an O node actually makes sense, especially for Crimson, or if we should be thinking about groupings of data and trying to apply like SIMD operations on multiple parts of what we think of as an O node at the same time. Like, batching batches of IOs, trying to operate in ways that make most effective use of time or CPU abilities. It seems like right now we think about things in terms of objects and creating objects and deleting objects and intermediate objects and translating data in different ways, copying data in different ways. But maybe we're trying to fit all of this into this kind of idea of how this is supposed to work, but it's not really the way that is most efficient. Anyway, I'm not sure if it means anything or if it's really the right way, if we should be thinking about it differently, but it's just something that kind of keeps poking at the back of my head.
Yeah, I think it's a good thing to keep in mind and think about for next week. Well, it seems like we have a lot to discuss still. Mark, do you want to do the paper discussion next week as well, or do you want to move that out?
We could move the paper discussion out. It's totally cool.
Okay.
Yeah, let's. I mean, if people want to keep talking about this, let's keep talking about this. It's good discussion. Adam, you had mentioned different things to think about regarding targeted hardware for BlueStore and CStore and how to think about this stuff. Do you want to update your document that you had been working on with kind of what we've been talking about and ideas and questions that for next week?
Well, I can create new, but updating the existing one is like detracting from its actual meaning. So
Sure. Okay. Maybe if we do a new document, maybe we could create a new thing in the Etherpad for next week. With I've gotten very bad at actually updating the discussion topics with all the relevant points, but maybe we could put together something in here that kind of summarizes all of the questions and what we should kind of go through next week. Anyone else that wants to jump in, feel free to. I can create a new thing for next week here. I'm going to do that right now. So continued ONO discussion. All right. So yeah, anyone that wants to jump in, I guess. We've got that set up for next week on the Etherpad. So feel free to update it and we can go through next week. Thanks. All right. Anything else, guys? Well then, this was a really good meeting. This is really exciting. All of the discussion, and I think this is stuff that we've got more people that are more familiar with BlueStore now, and I think we maybe have a chance of actually changing some of these things, both in BlueStore and then hopefully, the maybe more exotic and more interesting changes that we can make in Crimson. So excellent job, everyone. Looking forward to talking more next week.
Thanks, Mark.
Thank you, guys.
Thanks, everybody.
Thanks.
Yeah.
Bye.
See you later, guys.
Thanks a lot.